today again we're moving on further into 13, and today we're going to be looking at the diagonals of quadrilaterals. So on 13.2 we were talking about all the different properties of the quadrilaterals, and so today whenever we're talking about diagonals is when you connect a line on the opposite angles basically. So we're going to be looking at the properties of those diagonals today. So let's jump into that. All right, so the first one we're going to look at is the parallelogram. And again, I want to go ahead and let you guys know that that chart on the back of your page is going to tell you some more specific information about these diagonals. So if we look on the back on parallelogram, it says that the diagonals bisect each other and whenever you cross these. So basically what that means is whenever I end up drawing my diagonals here, and I end up drawing this diagonal and this diagonal, what's going to happen is they're going to end up bisecting each other. And what that means is that this line is going to be congruent to this one, and then this line is going to be congruent to this one. So the lines are going to end up cutting each other in half. They're going to bisect each other. So ladies and gentlemen, that's what happens whenever you end up drawing the diagonals of a parallelogram. Okay? All right, so now let's look at a rectangle. So if you look on the back of your chart, it says on a rectangle, the diagonals bisect each other, but also the diagonals are going to be congruent to each other. So if I actually draw my diagonals on here, so if I have a rectangle and I draw my diagonals, they are going to bisect each other, which means this side is going to be congruent to that side, but also they're going to be congruent. So that means these are all going to be congruent to each other. So that means from this point to this point would be equal, and this point to this point would be equal. So all of those lines, when they're bisected, are actually going to end up being equal to each other as well. Okay? Now the next one, for a square, the diagonals are going to bisect each other, and the diagonals are going to be congruent, but also the diagonals are going to be perpendicular to each other. So if I actually draw my two diagonals of my square here, they are going to bisect each other. They're also going to be congruent to each other, and also they are going to be perpendicular, meaning all of these angles on the interior are going to be 90 degrees. So ladies and gentlemen, that's what happens with a square. Okay? All right, so the next thing we're going to look at is a rhombus. So on a rhombus, the diagonals are going to bisect each other. So if I actually draw a rhombus here, rhombus, remember, all the sides are congruent over here. That means these are going to bisect each other. And then also, these are going to make a 90-degree angle right there in the middle. So those diagonals are going to end up making a 90-degree angle. They're perpendicular to each other. Okay? Now for a kite, if I was to draw my diagonals here, they're going to make a perpendicular angle right there whenever you do this. But also whenever you draw your diagonals, the long diagonal is actually going to bisect this diagonal here. So this would actually end up being congruent to that side there. So whenever I draw all of those two diagonals, the long one's going to bisect the smaller one. Okay? Now lastly, on a isosceles trapezoid, so remember this is only for an isosceles trapezoid. So if you have an isosceles trapezoid here, your diagonals are going to be congruent. So if I was to draw my diagonals here, that means, so this was A, if this was B, if this was C, this was D, that means A to D would be equal to B to C. So the whole diagonal would end up being congruent to each other when looking at this. So we're going to take these properties of these diagonals and we're going to apply it to our examples. So let's jump over to example number 1. All right, so on example number 1, it says the diagonals of a kite ABC is shown below. If the two diagonals intersect at point M in the middle and the length of DB is 36, what is the length of DM? So if I look from D to B, that's going to be my whole line. I told you guys earlier that longer diagonal is actually going to cut this one in half. So if I do 36 divided by 2, that is actually going to give me the length of DM. So DM is going to end up being 18. So just by knowing that that longer one's going to cut it in half, that is going to end up being 18. So I would just cut it in half. Okay? Let's look at example number 2. Okay, on example number 2, it says one diagonal of a rectangle has a length of 8x plus 2, and the other diagonal has a length of 5x plus 11. We need to find the length of each diagonal. So I know in a rectangle, the diagonals are going to be congruent to each other. So I can literally take these two diagonals and set them equal to each other and just solve for x. So subtract 5 will give me 3. I'm going to subtract 2, which will give me 9. I'm going to divide by 3, which is going to end up giving me 3. And so now I just have to plug it back into one of them because they're equal to each other anyway. So I'm going to do this one. So I'm going to do 5 times 3 plus 11. 5 times 3 is going to be 15. 15 plus 11 is going to be 26. So the measure of both diagonals is actually going to end up being 26. And it would be the same thing with the other one. 8 times 3 is 24 plus 2 is going to be 26. It comes out to be the same thing. So again, rectangles, your diagonals are congruent to each other. So those two diagonals would be equal to each other, and I can solve that way just by using the rules. Okay? Let's jump over to example. All right, looking at example number 3. On example number 3, it's showing me I have an isosceles trapezoid because my two non-parallel sides are congruent. So what I know is in an isosceles trapezoid, if you look on the back of your chart, is that the diagonals are going to be congruent to each other. So if t to v is 2x plus 5 and w to u is 6x minus 23, I'm going to set those equal to each other. So 6x minus 23. So I'm going to subtract 2, which is going to give me 4. I'm going to add 23, which is going to end up giving me 28. I'm going to divide by 4 on both sides, which is going to end up giving me 7. And it wants me to find the measure of t to v. So t to v is going to be 2 times 7 plus 5. 2 times 7 is 14. 14 plus 5 is going to give you a measure of 19. So again, I solved for x, and I just plugged it back into TV to get my answer there. So I used, if I have an isosceles trapezoid, my two diagonals are going to be congruent to each other. Okay? All right, let's jump to our last example. Okay, on example number 4, it says for the parallelogram below, QN is 42. So Q to N is 42. And Q to T is 2x plus 9. M to T is 5y plus 3, and T to B is equal to 2i plus 12. We need to find the values of x and y. So in this instance, if I look at a parallelogram, I know that in a parallelogram, the diagonals bisect each other. So what that means is that from M to T is going to be equal to T to P. So those are going to be equal to each other. So if you look real quick, M to P here, if I look at this, I don't have M to P. I do have T to P though. So M to P and T to P. So this and this are going to be equal to each other. So I can set those equal to each other. So I'm going to do 5y plus 3, and I'm going to set that equal to 2y plus 12. So subtract 2 would give me 3. Subtract 3 would end up giving me 9. Divide by 3, so y is going to end up being 3. So that's the value of y. Now I need to find the value of x. So Q to T is going to be congruent to T to N, or N to T. So it looks like the whole thing is going to be 42, and then QT is going to be half of that. So that means I'm going to take half of 42, which is going to be 21. So 2x plus 9 is going to equal 21. So I'm going to subtract 9, which is going to end up giving me 12. I'm going to divide by 2, which is going to end up giving me 6. So the value of x and y are going to be 6 and 3 in this instance, okay? So I used that this bisects it, so I just take half of the line to give me the value of x there, okay? So ladies and gentlemen, this is just taking those properties of those diagonals and applying them to my examples. You're basically just saying, this is what I know, so I know that these are congruent or these are being bisected, and I'm using that to find the answers of what I need, okay? So if you guys need any assistance or any help, I'd love to come by and help you out. Just let me know. Good luck.